effectively, I will try to open our mind about digital technology and the materiality of the impact of the digital technology. So I will not, again, on this point. I'm a member of the direction of EcoInfo. It is a professional network which work on all the impact of digital technologies, and our main directive is to act to reduce negative environmental and societal impact, and that's why I'm here today. So we will see the general context. We will speak about the digital impact and the tools we use to understand the digital impact, and all the different impact, in fact, direct, indirect, and rebound effect, how we can act to minimize. And also, I want to give you some elements to understand why we don't act, in fact. So the context, I think everybody here is familiar with the Anthropocene era, yes? The main responsibility of the global change we are facing today is our behavior. We are consuming a lot of resources from the planet, and to have energy, to have a lot of quantity of meat to eat, for example, for having an intensive agriculture and manufacturing. All these elements are the main points which are responsible of the Anthropocene era. Oula. Oh la la. Okay. It was not a new information, in fact. In 1972, the Club of Rome already produced a report which is known as the Meadows Report, or which is titled The Limit to Grow. And the conclusion of the report in 1972 was that we have to stop the growing behavior we have because we have a risk of system collapse. Okay, and this conclusion was done also 40 years later by another institute which take the previous result and propose the same conclusion. But unfortunately, we are continuing to follow the worst scenario provided by the Club of Rome. We have also other indicators to understand the situation. We can have a look on the country overshot day. This is an indicator, a global indicator that allows us to analyze what are the quantity of renewable resources we take on the Earth. Actually, at the Earth level, we need 1.7 planet, so we already pass the frontier. Obviously, each country has different behavior. Indonesia is near to the balanced behavior, but Qatari is not really balanced. There is also other indicators which are sectorial one. But even in this case, we can see that if we define 9 limits that we do not have to cross, 6 of the 9 are already crossed. Okay, so the 6 already crossed are climate change, biodiversity, and the mass extinction that we have today. Chemical pollution just last year, the destruction of soil, and change in geochemical cycles, and also last year, again, problem on freshwater cycle. I suppose, just to remind, I suppose that also you are familiar with this. Last time we have had such quantity of CO2 in the atmosphere, it was in the Pliocene era. At this period, we have trees in Antarctica. We have the sea level, which was 50 meters upside today, higher today, and an average temperature which was 3 or 5 degrees above. Okay, so it's just a physical laws. We have too much CO2 in the atmosphere. We will trend to this situation probably. Okay. We have a lot of, other consequences, but I will not enter in the details. Oh, sorry. So this graph shows us the direction that we have to take following JEC recommendation. Does anybody know the part of the digital technology? No? So it's something around 2 to 4% of the global greenhouse emission. But it's a rapid growing sector. It's not comparable to other sectors. Usually, it is compared with the aviation one. I think it's a good comparison because it's not only in terms of greenhouse emission, but also in terms of who is using aviation and who is using digital technology. It was the same person, okay? It was affluent people. It was not poor people, in fact. So in terms of biodiversity, I think that this point you know very well. We are facing to a 6 mass extinction. The life is dying. Okay, this in simple words, the life is dying, and we are part of the life. So we are here. Digital technology is usually presented as a solution for us. Okay, I would like to show you that it's not really a reality. It is, in fact, part of the problem. So who is using technology? So around 4.7 billion persons are connected in the world, okay? But you can see that it's mainly, again, affluent people. We have 3 axes of analysis to better understand the problem. We can have a look on the hardware, on the software axis, and on data one. Obviously, the real impact are done by the hardware part. To have functioning internet and numeric tools, you have to have cables, you have to have satellite, you have to have data centers, you have to have antenna, you have to have phone, computers, and so on. So you have to have a lot of material, a lot of hardware, in fact. Oh. Okay, so to understand the impact, we use LCA, life cycle assessment. This is a standardized evaluation method. The interest of this is it is standardized. This allows to identify all the problems provided by the hardware fabrication, manufacturing, and it allows to move away from a carbon-centric vision, because the problem is not only CO2. It was all the other barriers we already crossed, okay? We have impact on all the barriers, on all the sectors, sorry. So when we analyze the life cycle of a product, it's not, this point is not only for digital technology. This method could be used also for whatever you want. You have to define a perimeter and describe life cycle of the product, having a look of ingoing and outgoing during each stage of the life of the product. Okay, so doing an inventory and doing assessment and a conclusion. When we have a look on digital technology, it's really specific because it's a technology really complex. We need around 70 materials when you want to build a smartphone or a computer, okay? Glass, ceramic, and a lot of metals. So all these materials you need to be extracted. This is the first step of the life cycle. We have to extract the raw material. We need sand, we need minerals, we need oils. All this extraction will imply pollution. Pollution because we need a chemical reaction to extract products. We need a dissolution process with water and acids. We need also to heat sometimes the product we extract from the earth. We need a lot of water. And sometimes we need to desalinize water. For example, in South America, there is a lithium extraction place, and we desalinize the ocean water, and people around don't have water to drink. We have also, obviously, sorry, we have also children oppression and exploitation in some places, in Congo, for example, and armed conflict about these resources, okay, because there is a lot of money to do with. So this is just the first phase. Obviously, at each stage of the life cycle, we need energy, okay, so we need to produce energy and electricity. I will not repeat this point each time. Digital technology use some of raw materials in high quantity. Okay, some of them are used in other industries, but some of them are used only or mainly by digital technology. Okay, so for example, gallium, indium are essentially used by digital technology. And coltan, for example, also in Congo, as we seen just before. During the life cycle of the product, we have a lot of transportation phase. We have to transport because all the raw material are all around the world. We have to take them and to transport to the plant which will transform in a new product. Okay, so we have trucking, aviation, maritime transport. Okay, so at different stages for the raw material, for the manufactured one, and also at the end of the life when you have to transport the waste. You have also a direct impact in terms of manufacturing. Everybody has already, you probably already, sorry for words. Okay, so social problem in China about manufacturing. Okay, we have chemical problem with manufacturing because when we try to make a wafer, for example, a wafer is just a circle of silicium, which contain all the microprocessors. Okay, when you have to build this, the smaller you try to do it, the most, you will increase the quantity of energy and the chemical product you need. Okay, so for example, for one wafer, you need 80,000 liters of pure water, which is not pure after the process, obviously. And we are producing a lot of wafers in the world. And you have a social problem also, suicide, and so on. This is the phase we usually think in first when we speak about the digital technologies. It was the usage phase. We can see that it is not balanced again an American people has around 10 connected devices, okay, but and consume around 140 gigabytes by month. An Indian has only one connected device. Once again, we can see in the usage phase that it is not really balanced. We have a lot of connected objects, and if you have a look only on the energy, electricity consumption, Internet could be considered as the third country in terms of consumption of electricity. Oh, sorry, this is the French, just an image, the same thing here. In terms of usage, I gave you some elements to better understand. This is order of magnitude. This is not a precise result, okay? It's really difficult, in fact, to have a precise result when we try to do a LCA, because there is too much quantity of information to take in account. So this could give us an idea of the impact, but it is not precise. So for example, when you're processing data, so here you have the reference here of the studies which was used to produce these numbers. So when you're processing data, it's around 2 to 5 grams by hour, okay? The most important here is that you see that 1 year electric consumption for a server which do nothing, just storage or just waiting, it's around 30 to 50% of the maximal consumption. So a server which do nothing is consuming around 50% of the maximum. Another important point which is given us by the LCA is that the distribution of the impact. You can see that the usage phase, for example, for a server, is most important than the fabrication one. This point is true when you take into account a server which with 7 years life, okay? If you take a laptop with 4 years life, you will not have this result, okay? So the most important point here to retain is that if we want to minimize the fabrication part, you have to keep your system the longer possible, as long as possible. The last stage of the life cycle is the end of life of the object. You will have a lot of waste generated by or production or manufacturing, 50 million tons in 2019, and it's growing, obviously. Only 17%, oui, 17, c'est ça? J'ai un doute, hein? 70, oui. Percent of this quantity is come back to the system, and 80% is lose. So in the waste, illegal traffic, and finished in Africa, for example, in Ghana, it is the most known. This scenario it's a little bit better in France. We are near to the 50% collect. This is the collect reference. On this part, we have 10% which is burned, 40% which is wasted, and only 75% which is recycled. Which on this part, we have also a recycling rate. And for example, on a smartphone, we have only 20 metals recycle, we can recycle on the 17 inside. Okay, only 20 on the 17 inside. Sorry?
20 or
20.
12?
20.
20 sur 17?
20 sur 70. On 70. Sorry for us. Hein?
20 on 70.
Oui, 20 on 70. 20 metals on 70 available. Sorry for the English. It was the first time I was doing this presentation in English, so sorry. So you have, we have seen here that we have a lot of direct impact of the digital product. But I would like to show you that there is also societal and indirect impact that are, in fact, probably most important than the direct one. Just after. Oui, OK. In terms of hardware, non, mais il y a un problème. OK, sorry. I will do the indirect impact before, after. In terms of hardware, we have, we can act at the first levels, providing the right services and properly sizing when you purchase a PC, okay? You can, the most important part is to have a lifespan as long as possible because of the impact of the manufacturing phase. So you can mutualize, reuse your material. When you purchase hardware material, you have to choose a responsible society, for example. Not a publicity, but the only one which do this in a smartphone area is Fairphone, for example. So the second axis you can have a look is the software one. The software is the brain of your hardware. If you don't have software, you have a brick. You have direct impact of the software. If the software is bad designed, you will have a lot of energy consumption, you will have a lack of performance, and you will need to have a new material which is more performant. Okay? So the software is part of the impact of the digital technology. It is not a direct one, but in terms of impact, the software acts. So you have, if you have to design software, you have to have an eco-design approach, okay? And you can seek also to open source products, and which allow us to reuse and mutualize the effort of the development. You have to think also of sustainable digital service, not to think only on the software which is on your machine, but thinking all the service you want to put in place. So this point could be integrated in the reflection. The data also, the same thing than the software. It's probably the most immaterial aspect of the problem, but data is the main reason of why we use digital technology. In fact, it's like your brain. We need to manipulate and to process data, and the digital technology allows us to do it. So this is the reason of the existence of the numeric tools. Data is important because it's precious, unique. The raw data are unusable. You have to add data when you use it. You have to add metadata, in fact. The acquisition has a cost, an environmental cost. When you launch a satellite, when you are doing a maritime campaign, you have ecological and obviously financial cost. So you have to put in place a solution to keep this data as long as possible. And this is the exploitation of the data we gave us, which give us knowledge. But data is also something which can be used in a bad way. You can use data to manipulate and to survey people and society, big brother society. Okay, so it's also a tool of power. We have an exponentially growing volume of data in the world today. The main subject in terms of data is the video streaming. Okay, this is really the main subject. Email are not really a subject. If we have a look on the data part, email is not a subject. Okay, so you have to be to have attention when you send email. Okay, no problem for this, but it is not the subject, the main subject. So the third video streaming, web, and gaming. Okay, the marketplace is only the sixth one, audio streaming. So in the 10th, you can see the email in the 10th first. So we produce in 2020, we produced 40 zeta octet. Okay, so 1 zeta octet is just a stack of 1,500 billion of CD-ROM. It has 10 times the distance between Earth and Sun. Just 1 zeta octet. Okay, so we produce a quantity of data which is out of brain. We can't really understand. So the direct impact of the data, of the same thing that for the software, you have a direct impact on the hardware because you need a lot of network storage and a lot of storage and processing means. And you need also network which allow you to facilitate the transfer of data. Okay, and you have indirect impact in terms of surveillance, manipulation, and power, as I said just before. So if you want to act at the first level for data, you have to think in terms of sobriety. Limiting data processing and exchange. If you want to keep them as long as possible, you have to think in terms of open data and open science. And FAIR is just an acronym for findable, accessible, interoperable, and reusable, which is the things we have to do when you want to do open data. You have to adopt institutional solution and without multiplying. Limit streaming, video resolution, protecting privacy, limit advertising, and so on. So, in terms of indirect impact, we have also a lot of things to take in account to better understand the digital technology impact on our society. We have a phenomenon of acceleration in terms of flows and products, but also in terms of financial. We have a quick obsolescence phenomenon also, which is specific to digital technology, not completely specific, but the speed of the obsolescence in digital technology is really specific. We have also a globalization and increased dependency. We have dependency for the raw material, for example, but we have also dependencies in terms of infrastructure. The internet infrastructure is something which is at the Earth level. Okay, so it's, we have interdependence between countries. This increased complexity of our society, and we could question about this point in terms of stability. If we have instability in terms of climate changing, and what can we have a stability of the internet infrastructure if we have on the other side a stability which is provided by the climate change. We have also unequal power relation between states and private corporation, private company. In terms of dematerialization, we have seen just before that it's not really dematerialized, okay? We have a big infrastructure to be able to use digital technology, and in terms of paper, for example, it was a failure. We print a lot of papers. We continue to print a lot of papers. We have, in English, I'm not sure it's correct, but a digital device, fracture numérique in French. The fact, for example, that some people are excluded from the digital technology usage. My mother, for example. We have optimization and efficiency, which is the heart of the digital technology. Digital technology helps us to improve efficiency. We have a problem with the efficiency because it is the source of the rebound effect. The rebound effect explains us that if we improve efficiency, we will automatically improve usage of the technology. Okay, so each time we improve the efficiency of a technology, we improve the usage. All the environmental gains you can have in terms of efficiency will be compensated by the rebound effect. There is some example in your house. If you use $1,000 to euros to pay for having 20-degree temperatures, 20-degree temperature in your house, and you decide to have a new heating machine, a new windows, and so on, you will continue to spend to 1,000 euros to have 22 degrees. Okay, this is a good example of rebound effect, in fact. You improve efficiency, but you consume more. We have a lot of social and human impact also. These are just examples. In terms of concentration, when you work on something, perhaps you already noticed that you have a mental construction. If somebody interrupts you, you leave this mental construction, and it could take up you to 33 minutes to refocus on the same level of concentration. We have also information fatigue syndrome, which is linked to the quantity of information we receive by mail, by notification, and so on. We have a problem of addiction, which is on social network or on gaming, which is voluntarily done by social network. Okay, so we have just phenomenon of addiction. We have also some ethical issues when we have a look on the situation on a more systematic vision. We can understand that technology is not neutral, okay? And we have phenomenon of surveillance and manipulation, as I said just before, in terms of dilution between private life and public life, in terms of fake news, in terms of orientation of population. So we have to challenging the concept of progress, which is given us by digital technology. And Ivan Illich, which is a philosopher, proposed a radical monopoly vision, which explains that the technology, it's not a monopoly due to one brand, but just a monopoly due to a technology. Okay, we are just oriented in one direction by a technology. In terms of artificial intelligence, the recent development of chatbot, for example, crystallize and concentrate many elements of questioning. In terms of development of the artificial intelligence network, we have a lot of energy consumption to train them. We have also the use of low-cost human resources to validate that the answers proposed by the chatbot are correct. We have also a lot of societal impact in terms of artificial intelligence. Military proposed to have autonomous weapons, for example. Do we want really to develop automatic and autonomous weapons? We have also, I already said this, Big Brother society, conception of living, but also deep fake and so on. We have also a specific problem with neural network. It was the transfer of cognitive biases. The neural network have the same behavior than us. They have the same default also. In terms of racism, in terms of... you have already seen this example, I think. So in terms of first level action, we have the same point than for data, because it was really linked. But we have also to think about the meaning of our activities. When we worked on this type of subject, it's important to take into account the consequences of the development and the development of this type of product. So I hope that you are convinced that digital is something concrete. I will just propose you some high-level action possibilities, because I have no specific solution in plus of the precedent one. So the goal is to avoid to be in this situation. So I have, as I said, I have no simple or ready-made answer. So you have to accept that this is a complex situation. We have to accept, not you. We have to accept that we are facing to a complex situation. All the things are interconnected, and digital technology is part of the problem and accelerates the problem, in fact. This is the most important point. Digital technology accelerates the problem. So if we accept that we have, so we are facing to a complex situation, we have to think in a complex manner. We do not have to divide the problem in silo or in little problems. We have to think with a systemic vision. So we have to think, and to think we have to slow down. Okay, this is important also. We are not in a society where the proposition is to slow down. But be careful. So, yeah, you read, it's okay. We have to slow down to think better, and when we think, we can beginning to refuse, reduce, reuse product, repurpose product, recycle product. This is the classical means we can put in place. We can think in the direction of sobriety. The sobriety is to satisfying our basic needs. Okay, it's not creating new needs. It's just satisfying basic needs without creating new ones. So by adopting a systematic vision and using less resources as possible, few resources as possible. So low technology is a good answer of sobriety, but it's complicated. I think it's a real challenge for engineering. Produce low technology is sometimes simple, but sometimes it could be really complex, in fact, because we want something resilient, robust, easy to maintain, with low dependency, okay? So it's really complicated, in fact. And low-tech is a challenge for us. A bad word, I don't know, un gros mot en français, en anglais, je ne sais pas. Degrowth. Perhaps we have only one solution. In the time the GIEC proposed to degrow, the deadline proposed by the GIEC is 2025. So do we have time to think another solution than degrow? Degrow is not, is just decoupling economic growth from the consumption. No, so it's just change our indicators, sorry. Okay? Degrow is not, it's just a financial degrow. We can propose progress in terms of human life, even if we don't grow in terms of GIB in English. So we can focus on robustness and resilience, and this is the counterpart of efficiency. Nature is robust and resilient. Nature is not efficient, for example. We have to take the time to questioning our objective and the meaning of our activities. When you are in an organization, you have more power. Okay, you can act by yourself in your life, but the act you can put in place, just for example, don't take the plane or eating less meat, is just at your scale. Okay, if you are in an organization, you can influence the organization and having a more powerful action. In terms of repartition, we estimate that we have 40% in terms of individual part and 60% in terms of collective one. So each time you act in your organization, you act on the 60% part. Educational and research institutions have specific role because we transmit values and we are example for others. So when we are in a research institution, perhaps we have a more important responsibility. In French, we have a legal support for this. Okay, it's recent. We have the numeric law, which was acted in 2021. And okay, just it's French point. I think that the most important point when you are in an organization is to put in place cross-functional working group. This is a good point to start the reflection and to put in place action. You have to think out of the digital point, obviously. You have to just take into account all the points you can consider to avoid impact on environment. So we have to give time to people. You have to train yourself to understand what are the issues and the problems. We have to question our activities. And in terms of digital, we can think using eco-design software and data in the direction of open science. You can enlarge your thinking also, integrating sustainable development goals of the UN organization. all these points are linked, in fact. Okay, if you have no poverty, if you have education of quality, you will integrate and improve all the environmental impact, in fact, because people knows. So deadline is short. As already said this point, we do not have time to a techno-solutionism solution, okay? Moreover, a technological solution could create a rebound effect. We have deployment delays. Even if we are able to put in place fusion technology, for example, we will need at least 30 or 40 years to implement this technology. And we do not have time to do this. Okay? So techno-solutionism approach is not really a good approach due to the deadline we have. So the efficiency, I already said. And we have also some barriers to action. I will just quickly give you some idea. We have a lot of cognitive biases. Okay, the most important, a good example is the last one. If at the end of the month, you have $50 supplementary on your salary, you will be happy. But if the company take you 50 euros less on your salary, the angry will be higher than the pleasure you have to receive 50. Okay, so we don't like to lose something. This is probably the main bias which does not allow us to act, in fact. So some people say that also we have a brain which is not adapted to abundance, and we have abundance. Not everybody, I know, but we have abundance here in our society, and we are responsible of the problem. Okay, it's our society which is responsible, not the people who don't have abundance. Okay, so this is just the same thing. We have a godlike technology, but Paleolithic emotions and medieval institutions. It's not mine, it's Tristan Harris. So we have a lot of biases. Donc I don't enter in the details. We have also social breaks. We are in a society which try to retain the maximum of your attention. I said addiction just before, it's the same thing. We have a problem also with everything right away. We want to have everything now. And the digital technology does not help us to work on this default. I think also it's important to think that we are, I don't know exactly the word, sorry, Stanley Milgram experiment explained us that we are submitted to authority. So we are a society which is structured, okay, with a leader, and so we have the habit to obey. It's okay. And also we have a lot of breaks in terms of greenwashing and like society like Total, tobacco companies, which gave us example of greenwashing. Okay, so this you can have a look on the slide. Yeah, okay.
Yeah, because if you want to have questions from the
floor, okay, it's
no,
the conclusion.
Your conclusion, perfect.
Sorry. So, just a summary of the presentation. So sorry for the English.